Rolle's theorem is by mathematician named Michael Rolls. This E like this. Michael Rolle is a mathematician that he doesn't believe in calculus early on in his life. He's like, calculus doesn't make sense. This is BS. And then everybody's like, yeah, he's my guy. This is my guy. Of all the theorem, I need to memorize this one. And then later in his life, he says, okay, calculus is actually okay because he's like, it's actually important to solve a lot of different kind of problem. So he come up with something called Rolle's theorem. So I'm missing the O for a reason.
Everything happens for a reason.
So I'm gonna talk about O. O is an easy way to remember this theorem, but give me a second. Let me give you a condition first. So the first condition says f of x must be continuous between bracket a comma b. Second, f of x must be differentiable. Parenthesis a, parenthesis b, this is open interval. So make sure that this is an open interval and this is a closed interval. Right? So they have three conditions. The third condition says f of a must equal to f of b. Now people are very visual person, they can kind of see what happened. The result is then there is C, there is at least one C. There's at least one C in open interval A and B such f prime of C is equal to 0. With that being said, I'm matching this part 0 and O right here. F prime C is equal to 0, and kind of think about every time you say F prime C is equal to 0 is for Rolle's theorem. So yes, there's an O there and also 0. Kind of think about those things when you think about Rolle's theorem. Now, why is it open parenthesis? Why like A and B not including the endpoints, right? Now, a long time ago, I told you when it's not differentiable. When is not differentiable? Can you tell me one case is not differentiable? Well, yeah, it's not continuous. Okay, that's good. That's actually qualified. So not continuous. There were multiple ways to say not continuous. There are asymptote. Right? There was asymptote, especially vertical asymptote. What else is not continuous? Is maybe a hole, right? Good. There is vertical tangent as well. That kind of qualify for sharp turn, but I'm gonna say sharp turn as well. And lastly, which is I have not mentioned before, is the endpoint. Endpoint is not differentiable. Therefore, the C is not because that. So endpoint is not differentiable. There's something I did not mention before. Then there is at least one C in parenthesis A, parenthesis B, such f prime of C is equal to 0. So you gotta understand when it's not differentiable, when it's not continuous. Obviously, the things that cause not continuous, it would be like an asymptote, vertical asymptote, or hole. Vertical tangent, that's another one. Sharp turn, a cusp, right? Cusp. And cusp is like vertical tangent and sharp turn at the same time. Endpoint. So endpoint should never include it in terms of Rolle's theorem. Now, with that being said, you understand all the things. Now we just have to be able to apply it. We just have to be able to apply it. But let's talk about the example of Rolle's theorem, and then talk about counter example. Example is, again, I have A and B has to be a same output. FA has to equal to FB. Imagine it's continuous and differentiable, right? Then the easiest one I can think of is like this. And guess what? This is f prime of C is equal to 0. You can have one value. Can you have more than one value? Yes. Between A to B, can I have more than one value? Yeah, I can have something like this. C1, C2. I have more than one value. Yeah, let's close circle, both sides.
No, like what is like why is it?
Because this slope is equal to 0, or is it f prime of C is equal to 0? Right? This is the last example, which is the extreme example. What if I says there was a straight line? Well, straight line, there was infinite amount of C. The f prime of C is equal to 0, right? As long as they have the same value. So you have to have the same output. If it's not, then it can be a diagonal line. If a diagonal line f prime of C is not equal to 0. So imagine that if you have you have a point right here, then it's straight line, then there's no derivative equal to 0. So that doesn't work. But this will kind of give you guidance what mean value theorem means later. But right now, we just assume that FA equal to FB. Now, I'm going to give you a counter example, which is the example doesn't work. I think I spelled counter wrong. But counter example doesn't work is like, okay, if f of A does not equal to f of B, of course. But I'm going to give you another example where it's not differentiable. When it's not differentiable, there is no point here where slope is equal to 0. Because at this point, f prime of x is undefined. And yes, you can have maximum, but Rolle's theorem does not apply here. Got it? So all first three cases apply. The last one doesn't apply because it's not differentiable. It can be not continuous too. You gotta think about all those counter example on your homework. Lastly, examples. I'm gonna say f of x is equal to x4 minus 2x squared. Find all values of C in the interval 2 and 2, where Rolle's value apply. Okay? Then what we can do is check f of x. Are they a continuous function? Do you think that's a continuous function? Good, it's continuous because they are polynomial. So between A to B, bracket, by the way. Sorry, let me rewrite that. So must be continuous, because what does that make not continuous? When you have an x on the bottom, like 1 over x minus 1, it's not continuous at 1 because there's a there's a hole. I mean, there's a vertical asymptote, sorry. There's not a hole. If you have hole, it's also not continuous in this case. So f of x is continuous. First condition is fulfilled. Second condition, f of x is differentiable. Well, is it differentiable between a to b? Yeah, if you take a derivative, it's 4x cubed minus 4x. It's still polynomial, it's not anything denominator can equal to 0. So therefore, it is differentiable. Third, what is the third condition? F of a and f of b. So in this case, it's going to f of the negative 2 is equal to f of 2. So f of negative 2 is negative 2 to the fourth minus 2 times negative 2 squared. That's going to be 16 minus 8 equal to 8. Same thing as 2 to the fourth minus 2 times 2 to the square, 16 minus 8. So is f of a is equal to f of b? True. Therefore, you can try to do Rolle's theorem, says f prime c equal to 0. So you can say f prime c, which is, you did that yesterday. That's going to be 4c to the third minus 2c, and is equal to 0. So you can factor out, sorry, it's going to be 4c. So we can 4c and c squared minus 1 equal to 0. C equal to 0. C squared minus 1 equal to 0. C equal to plus minus 1. There were 2. So there are total 3. There's 3 c's here. Now, you can have more than one c. You can have infinite amount of c. But in this case, there's 3 c's. Which is something that you did before. Why do I change to c instead of x? I can do whatever I want. Because x and c doesn't really matter. You're solving for c. Because here we just want to find out what c is. But it's up to you. You can leave as an x and solve for x and find out. Tell me that's a value of c. I don't care. Yes.
If you get the same value, then you can like use the theorem.
Yeah, if they both at an endpoint, if you plug in, if you got a same point, so that math means there has to be a slope equal to 0 in between a and b. Okay, let's look at the graph. You look at the graph. You see this point, this point, this point. All they are equal to 0. F prime c is equal to 0. So that's how you check your answer. See, if you got those points, it's equal to 0. Is f of 2 equal to f? By the way, this is how you build a table. It's really helpful because you see negative 2 is 8, positive 2 is 8. Right? And you also have all those critical points there. It's all given to you. So the minimum extrema is going to be negative 1. The maxima is going to be 8 because the highest point is at 8. There was 2 8s, but you can say maximum value is 8, minimum value is negative 1. Voila, that's it. That's for today's lesson. You're going to start your homework? Yes. Yeah, you can see 8.
Can you go back to the note? Oh, I see.
That's how you check your answers too. You can look at the answers there. If you want to find extrema. That's today. If I want to find extrema, I'm plugging negative 1 into the function. I'm plugging 0 into the original function. Which is I did over there, the order value over there.
These are the critical points.
Negative 1, 0, and 1. And the endpoints, negative 2 and 2. Which is all the value there. Which is pretty cool. Now, do you have to plug in every single integer? No. Only critical number. Because at here, it happened to be every single integer.
Wait, if the function isn't continuous, that means like you can't apply Rolle's theorem, right? Yeah.
Yeah.
So if, like
No, it's not continuous depending on where it is. So let's say 1 over x, right? 1 over x is not continuous at 0. But if the theorem is asking between, I don't think 1 over x is a good one, but between 1 to 10, then 1 to 10 is continuous.
Okay.
So long as that interval is not a asymptote, then for the continuous part, you still can apply. Now, are they differentiable? Are they f of a equal to f of b? Is really depend on each case by each case.
And then like for 1 over x, if they give you like -5 to 5, that wouldn't, you could apply rules.
Right. You can say rule theorem does not apply. Automatically done. Because you can say at x equal to 0 is not defined and 0 is between -5 to 5. When you look at a function, most of that's a good question. Somebody's asking, how do you know the function is differentiable? Well, I would tell you that it's not differentiable if after you take a derivative, you have x on the bottom or some type of x. If you have 2x minus 1 on the bottom and that 1/2 is in the interval, then that's not differentiable. When it's also not continuous, not differentiable, you should pay attention on secant, cosecant, tangent, and cotangent because all those graphs has asymptotes. So those are the things you gotta pay attention to. Polynomial on the bottom, yeah, sometimes it can be not differentiable, but sometimes it doesn't be. So if let's say 1 over x squared plus 1, on the bottom will never equal to 0, first of all, because x squared plus 1, that is fine. Actually, that one has a maximum. So if you just graph, I'll repost on group chat. See like this actually have a maximum between this because between -1 to 1, it does not cause the bottom not differentiable or not continuous.
What if it was x squared plus 1 over 2?
I don't know. X squared plus 1 over 2. Yeah, that one should be fine. It's actually the perfect thing to test. Because if bottom has x and it's not like not able to solve. For example, x squared plus 1 equal to 0, you're not able to solve that because you move the 1 to the other side, it's x squared equal to -1. X squared does not equal to -1, only equal to -1 at I and -I, and that's not a real number. So it is still fine. So that would be a good test question right there, 1 over x squared plus 1. Just because it looks like it's gonna be bottom is not differentiable, but it's not. Doesn't mean I'll put on a test, but it'll be a great test question. So I will make a for those of you guys says I will not be here tomorrow. I'm gonna make a video of mean value theorem. I will tell you how important mean value theorem is. It's on every single damn test. And it's 100% show up rate. I would concern about a question that's 100% showing up, just because for me, it's really easy to study AP exam if you really think about it. If you just understand those 100% type of question that will show up, and you don't have to be able to do anything like related rate or whatever, you're still gonna get a 3 or 4. Honestly, if you understand all the question that's 100% showing up on the test. So if you really want to be AP exam, just knowing those things. So mean value theorem is one of them. It's only worth 1 point, but hey, it's better than 1 point that barely show up than 1 points always show up. So that beats everything. So like say equation tangent line, it's 100% of the time will show up. Definition of derivative in terms of the using the format of definition of derivative, that will 100% showing up. So if you just understand those questions, if you understand chain rule, 100% of the time showing up. So and not only show up, it show up multiple times. So if you just understand those questions, you should get fine on AP exam. You might not do fine in my class, but you'll be fine on AP exam because you know those are the questions that you will show up 100% of the time. And all you need to do is understand 42 point out of 108. That's a 3. Matter of fact, you don't need to understand 42 questions because guess what? You're going to get lucky on some of them. Right? So you probably need to understand 35 points. 35 questions, that's always 100%. Mean value is one of them, so you already knock out one tree. You just have to cut down 34 more trees, and rest of them are just Christmas. And you still can get an AP exam. What? No, this is our way to study for a test. AP exam, I can do like a 2-hour course on how to pass AP Calc. But you have to understand that specific question that will show up. Now, that's required you know how to take a derivative. That's required you know how to do chain rule product or quotient rule. That's required if you know how to do certain things. Integration, basic integrations.